Friends, on this lesson, I will introduce the M30 series hashboards and the oscilloscope to detect waveform. And after this, continue to introduce the system log of background and some knowledge about the M50. Let's begin. And on my head, this is M30 series hashboards, and the M30 series hashboards including many types, such like M30, 30s, M30s plus, plus 2, and M32. Many types, so, and each type, the count of chips on the board are not the same. So this lesson, I will just introduce the different, the M30s with the M20s. The last session, I had introduced the M20s. We know that the M20s, the power supply, we already set at 30 watt, but the M30 series hashboards, because of there are many types and the chip count not the same. So the voltage of power supply when you test a board also need to set different. How to set this power supply? We need according to calculation in the guidance file. Here have a description how to set and how to calculation. For example, in my head, this board, the first step you need to know how many chips on the board. You can also have a test in the mobile external like this. In order to acquire how many chips on the board, you can just insert the test cable and have a test in the mobile, like mobile program. Like this, after you run this command, how many chips you can load? There are 129. And this minor type is M31S plus. So according to the chip count, and we can have a calculation 129. We know that on the board in a group there are 3 chips, so it divided the 3 is equal to 43 chip group on the board. And according to the guidance, we set the voltage, standard voltage of chip group at 0.31. This voltage multiply the chip groups, then is the power supply voltage we need the setting. Now it multiply 0.31 watt is equal to 30.3 watt. So this board we have a calculation. Then below the voltage we need the setting. So we set the voltage at the supply. We set it just now the result 30.3. So on the M30s, each type you need to have a calculation like this. And after this, set the power supply, then we can begin to test the board. Compared to MS20S, we know that the first step, when you measure the voltage of chip growth, on the M20S, it lead over 0.3 volt. But on the M30s, the voltage of chip growth just lead over 0.15 volt. It can work normal, or signal can work normal. So from this, you know, this M30 series hashboards is easier than the M20S for repair. Always the voltage of chip groups are balanced. If you found one group that is low than 0.15 volt, you also need to replace a chip to boost the voltage over at least 0.15. But always the average still keep at 0.3. But it always if over 0.15 volt, it can work normal. So this is easy than M20S. How to select the right chip for replace? So there we have Excel to instruction. According to this Excel, we always use 5 types to repair. Can repair all types of M30 the hashboards. And this is the first step. When you repair the M30, first set the available power supply and have a measure at the voltage of chip group. At least around 0.15 volt. Second, still check the LDO. The LDO output still is 1.8 volt, and the supply is the same. And the power supply of the first pin is the you count fluent CF belong to the chip groups. Counter lance group. The positive for the lance group is the supply of the first pin. And sometimes if you need the when you repair the LDO circuit, the first step you can replace the LDO. If still a problem, you need to check the first pin to see if the input is enough or not. Always at least the input voltage lead over 2.2 volt, then it can make sure the LDO work normal. If the input is not enough, you need to have a measure to the you need to measure the lines, the positive lines group. The lines group, because it provides the voltage to the first pin of LDO, the total lines group, the voltage. If it is low than 2.2 volt, it also lead the input voltage loss. I just have said that each globe is lead the voltage lead over 0.15 volt, but if all globe is just only 0.15 volt, the input, the total length globe, the voltage is not enough. So sometimes you need to boost some globes to boost the voltage in order to make sure the first pin there is enough voltage to lead over 2.2 volt. But this case is a little difficult. You need to balance the voltage. This is different with M20S. And the last 8 LDO still seen as M20S. It provided by the booster circuit. So the main structure of M30 almost the same as M20S, and is easy to repair than M20S. After you check the voltage of chip globes and the LDOs, then you can start to measure the 4 signals on the board. Still the same 4 signals. One is RST, second COK, and third is RXD, the fourth is TXD. You can measure and repair the 4 signals one by one. Reset is the same method as M20S, still the same commands. We use these commands to repair the reset signal. The echo 0 set reset too low, and echo 1 set it too high. And the reset wouldn't repeat again. And the second is the COK. COK compared to M20S, there is a little different, and there is easy than M20S. We know that on the M20S, there are several clusters like this, several clusters on the board. On the full M30 series, always on board just one cluster, and it located in the first chip. It transmits from first chip here to last one. So if you check the COK, the first step you check at the first chip. Second, you check at the last chip to see is normal or abnormal. But we know that on the M30 series hashboard, the chip types there are a lot of chip types. So the voltage of COK is not keep the same as M20. Is M20 the COK always keep at 0.9 volt. But on the M30 some board it is still 0.9, and the other boards, some other boards not the same value. So if you check the COK, you'd better choose the oscilloscope to detect waveform. Just see the waveform is normal overnormal. It transmits from first one set to last chip, still keep the same waveform. That means the COK have no problem. Next, I will show how to use the oscilloscope to detect the waveform of COK. And this is a Tektronix brand oscilloscope. The bandwidth just need 100 megahertz is okay. And on the panel, there are two channels. We collect the probe at channel 1. When you power on the oscilloscope, you need to do some setting. First, connect the power supply cable of the hashboard. And this is the probe of oscilloscope. And this cable is the negative of the probe. You need to connect the negative cable to the negative pole of the hashboard. So I collect at first. Then you can use it to detect waveform. On the panel, we need to do some setting. We collect the probe to the channel 1, so we need to do some setting in the channel 1. Menu, we can place this button, channel 1. Then here is the menu of channel 1. We need to do some setting. The company, we need to select the AC, DC, AC, and the ground. We choose the AC. Under the probe, we select the 10 multiply. Multiply. And it's very easy, just these two settings. One is complete, and the probe is 10 multiply. The other keep, you don't need to do any setting. And the second step, you need to set the trigger. The trigger menu also do some setting. Press this key. And return to the screen. The type we choose the edge. We can have a look at the video pass on the edge. We select choose the edge, and the trigger source we select the channel 1 because we input from the channel 1, so we choose channel 1. And the slope is rising, and the mode output is okay, and the complete we also choose AC. AC. Then the setting have completed, and this arrow is the trigger level, trigger voltage. So we also turn it, adjust it belong to this 0 line is okay. Not over the 0 line. Turn it to below, turn it down below than the 0 volt. Now our setting have finished. Now we can begin to use the probe to detect waveform. Power on the hashboards. Now have power on and touch the COK test point at the first chip. Now we can have a look at the screen. Now this is the waveform of CLK. We know that the CLK is transmitted from first one set to last one. So the second step we can measure it at the last chip at the CLK. Now still keep it the same. This is I have adjusted the horizon to display the CLK like this, but the right waveform extension, you cannot always like this, the right CLK. At the first one, the same. One adjusted display like this. This I turned it to display like this is in order to at the same time you can detect TXD and RXD. Because the RXD and the TXD signal is the waveform is very short. If the time you adjust it per day is the time is very a little long that you can't capture the waveform RXD and TXD. So you can use this probe to detect the CLK, and the same as when you use the multimeter to detect waveform. You can jump the probe to any chip and have a measure at the CLK. For example, jump like here. If we still keep the same waveform, that it means from first chip set to here, still keep normal. That maybe problem just located at this section from this chip to last one. So in this section, you also can jump the probe to see a chip to measure the CLK. If it's normal, that you will narrow down the region you need to check. If it's abnormal, then you return from the transmitter direction, return and to detect until you found that the input of CLK have the normal waveform and the output is not the same. That means this chip is a defective one. You can replace a new chip. You can use this method to judge the CLK. And you also can use You can use the oscilloscope to detect the RxD and the TXD. RxD and the TXD let you execute the test command. At the same time, you can capture the waveform. If the command is run out, then the waveform will disappear. Now we can have a trial. As touch the probe at the RxD of first chip. Then run the command in the program. You need to have a look at the screen of oscilloscope. You can see here is a waveform when I execute the test command second times. I'll repeat it again. So when you execute this command, you can capture the waveform. Just like I was capture the RxD at the first chip, then I turn to last chip and execute the command again. You can see when I execute the command, still have a normal waveform. Do it again. It's very short. When the command run out, it will disappear. So you can use this method to judge the RxD early later you run the command. You can jump to any chip and run the command at the same time to detect waveform to see if with the input, if it's a normal waveform and the output, if it can keep the same. If the output is not the same, that means the chip is a defective one. Need to replace a new chip. This is the method who check the RxD, and it also can check the TXD at the oscilloscope. We know the TXD is generated at the last chip, and it is set to first chip. So you can, the first step, detect the waveform at the last chip. Touch the probe at TXD and have a test in the program. And the TXD is more short than RxD. Now you can, when I execute the command, you can find there is a very short waveform on the screen. Do it again. Now, so this waveform is very short. Just now I was tested in the last chip. Then the second turn it to first chip and touched the TXD. still run the command again. Now you can see it it appeared in the screen. Do this again. I'll repeat it. You can see here is a waveform. So you can use this method to judge is normal or abnormal. For chip, you just read the input of COK is normal and see the output of COK if it is normal. If you keep the same, that means the chip is a good chip. If the output is abnormal, not the same waveform, that chip is a defective one. The COK, when you power on, you can direct measure the waveform, but the RxD and the TXD need you run the read chip hard command. That time you can detect the waveform. This is the different. And this method, you use the oscilloscope to detect waveform. Also can use to repair the M20 as hashboards, the same. And sometimes aboard, if you use the multimeter to measure voltage, or voltage are normal, and you can't find the problem. So in this case, you can choose the oscilloscope to detect waveform. Sometimes on some board, the voltage is normal, but the waveform is abnormal. So you can use it to repair some hardboards. We know on the board there are 4 singles lead chip. The RST, CLK, RxD, and the TXD. The RST is only voltage, have low waveform. So we don't need to use the oscilloscope to detect waveform. It have low waveform. Next, I will introduce how to use lasers to short signals. Use this method to judge the signal pass or fail. We always use the tweezers to short the RxD and the TXD. We will demonstrate. We know when you power on the initial state of RxD and TXD on the board, they are over 1.8 volt. So on a normal board, when you power on the RxD is transmitted from first chip to last one. So at the last chip on normal board, the RxD is 1.8 volt. So measure the RxD at the last chip. Now is 1.8 volt. And the RxD is transmitted from first one, set to last one. So and it misses from first chip, set the 1.8 volt to last one. Now I use the tweezers to short the RxD to ground at the first chip. It means I set 0 volt to last chip. So it will fall to 0. I short the RxD to ground. Now you can see on a normal board, it can fall to 0. If I shorted the RxD at the first chip, but at the last chip, it can't fall to 0. That means the 0 volt transmit set to last one. There is a problem. We need to find it out at which chip located the position. For example, if I short at the first chip and it can't fall to 0, so I use the tweezers jump to any chip and short the RxD to ground. For example, here, if I shorted it to ground and it fall to 0, that means from this chip just along. I shorted from this chip to last chip, the full section, the XD are normal. So maybe the problem just from first chip to that chip in this section. Then you return and jump the tweezers to a chip and short. Use this method to narrow down the area you need to check. Use this method and repeat several times. You can judge which one is the defective one. At that chip, you short the RxD at the input test point of RxD. If it can fall to 0, that means normal. And then you short it at the output, and you found it can't fall to 0. That means this chip is a defective one. Next, I will show how to judge the TXD. We know the TXD is transmitted to the first one, last to first. So, normal at the first chip, it can keep at 1.8 volt. I measure the TXD at the first chip. Now, it is 1.8. Then I shorted the TXD at the last chip. It will, our normal board, it will fall to 0. Now, our normal board, I shorted the TXD, it can fall to 0. If it can't fall to 0 at the multimeter, that means the voltage of TXD transmit to first chip. There is a problem. We need to use the tweezers to short and find out which chip is a defective one. The method is the same like the RxD jump to any chip and short, but the direction is reverse until you find that the input of the TXD is normal, the output is abnormal. It can fall to 0. That chip is a defective one. So, if use the tweezers, it means you set 0 volt to see that it can set or not is it normal or abnormal. If it can to see if it can set to first to last or last to first. The RST, we know there are two commands. One is used to set high voltage 1.8 and echo 0 in the set 0 word. So you don't need the tweezers to short. This is the main method to repair WhatsMiner hashboards. You need to use them smartly or the method. The next I will introduce the background of wireless. We know the WhatsMiner tools. You can click on on it and look in the background of the miner. For example, I do demonstrate. You can click on it. Well, sometimes we need to analyze the background. Sometimes if the board can pass the read party test, but it can't run normal in the minus. In this case, you need to have a look at the API log or the log system. When you log into the background of minus, this is the first Windows, and this here showed that the time it run, how many time, how how long, and here is the average hash rate displayed here. Here displays the voltage of the power supply, and in this case there are 4 hashboards. SM0 is the first hashboard. Second, this is the second one. The middle SM1. SM2 is the third one. And here displays the frequency. And here is the hash rate of this board. Here is the 5-second average hash rate. Now, this board is not work alone, just power on only about 10 minutes. Is upper flick. The upper flick haven't finished. If the upper flick course is not completed, here we display 0. If we is work long and finish the upper flick, here we display 1. And here display how many chips on the board. Here is the temperature. If the board have some problem, the error code it will display here, and here have some description. Here is the first web page, and if you click on the state, here have some option. The first page is Miner states. Second is Miner API log, and third is system log. always we need according to the 3 page, do some analysis. Now, show example of the API look, the second page. Next is here is the Miner API look. If the miners have some problem, sometimes it will show the problem in the upside at the upside. If no problem, here is launching. Here the RD SM0, it means the next content is belong to the first hashboard. We always need refer to this parameter. For example, here the wall. The wall means the voltage of this chip is about 0.34 volt. And here is the temperature of this chip. The chip 0 means the first chip. And the lambs is about it means the hash rate of this chip is about this is the numbers. So we just refer to the frequency or temp and lambs. It refer to the 4 parameters. When you analysis the API look, here have a description. Frequency is this is the frequency or voltage. Loss is the hash rate of this chip. And on a normal board, the frequency almost keep all chips keep the same average average value. The voltage also the same. Temperature and the losses almost keep the same. The average value. Sometimes if you found one chip that the loss or any parameter that the value is far away from the average, that means this chip have some problem. If it can pass the leadership ID in the mobile, but it can normally and it always reboot. In the miner, you according to this, you need to replace the chip. And the next, scroll down. You can see here the ID is SM1, and so this parameter belong to the second hashboard, and the next one by one follow the next hashboard. If one board have problem, you only refer to this parameter belong to this hashboard. And if you found that this is this parameter is a problem that you need to replace a chip, but sometimes is not very exact. You need to repeat the speed more time. We open a web page of syslog. The syslog is here. If you click on this value, it will show this web page syslog. And in the system log, it record the running state from it power on to just allow you you look at the minus logs. And here the April 0, April 1, and the April 2. Here the April 0 is this information is belong to the first hashboard, second one, third one. From this information, you can know that the chip date is the chip type of the hashboard. For example, here is the 50 and 5B. All chip type is this same. If you found a miner that the chip type not the same, maybe this is a problem. Not needed that miner can't work alone. Always in miner, the chip types need to keep the same. If you found a miner can't work alone, maybe somebody mixed the hashboard it can't work alone. So you can check it here. And scroll down from here. You can see that the hashboard upper flag test start. When you power on, the first step is do the upper flag test. And you can see the below the upper the flag is up, is rising. If somebody or some hashboard have some problem, you can refer to this content. And you need to pay attention to the V and the P. The V means the voltage of the average voltage of this board. To see is normal or abnormal. If it's the V this value means that it's 0.35 watt, the average watt. Voltage is this. If it's very low, that maybe need the board loss balance. It means somebody or some hashboard, some and some chip group on the board. For example, slot 3 on this board. Some chip groups, maybe the voltage is not enough. On the M30, maybe it's lower than 0.15. On the M20s, maybe it's lower than 0.3 watt. You need to balance of voltage of the chip groups. The P is the percentage of good chips on the board. And it at least it over 90%. This board can work normal. So you need to pay attention to the P value. And see the problem if it's follow down to lower than 90%. It will lead the board reboot and it can work normal. If you found the P fall down, then you need to return to the API log and check that hashboard and see which chip that the loss is far away from the average value. That chip you need to replace. some hash board that in the wireless, the hash rate is not enough. Maybe is cost one chip that the loss is not enough. You also can do replace always if that miner is an old one. Some chips is will lose the function. We lead this problem. So the APR log and the syst log you need each other. This also need a lot of time. This case always you need see and need to look at the background, these pyramids and these contents. And you need to do a lot of practice. It's various. That's not easy. But just introduce I'm back. Just around the network disconnected. Now let's continue. And this picture show the MCT series that here is the label on the control control board cover that if you found that here is the VG and the type 60 is missed like this. VG version is made by the 9060 chips and the VF. If here the VF, here is this type is the 9058 chip, and the VE is 9050. Always the MCTs, the main chip is MCT. There are some 50, 58, and 60, but this not too much. Not too many this type of chips. the May is 1930, but you need to load this. And next, I will introduce the M50 hashboard, the new models. This is the M50 hashboard, and it's almost the same as the M30 series. The difference is you can see here in which in a chip group there are two audio. So compared to M30, M50, here is an ear group. There are two LDOs. The architecture of circuit is almost the same. I have magnified a picture to show the LDO, the different with the M30s or M20s. You can see that the LDO, the first pin, still connect to the third pin, and here is the input of power supply. The fifth pin still is the output. One LDO, this LDO, the output is 1.8 volt, and it supplies the voltage to the second LDO. This is the third pin of the second LDO, and it also connects to the first pin. And the the 1.8 volt of first LDO, it follows this trace provided to the chip, and the 1.8 volt also supplies the second LDO. The second LDO, so the input is 1.8 volt, the output is 0.9, 0.8 volt, and it provided to the chip. So the chip, the two LDO provided 1.8 and 0.8 volt to the chip. This is the main difference with the M30s, the new model. Just now, this is the first group, UP1 and UP2. The second group is like this, also the same. The first LDO, the first pin and the third pin connected together is the input, and it output 1.8 volt, and it provided to the chip. And also the 1.8 volt provided to the first pin. 68 chips is 5 nanometer chip. So it's much better than M20s and 30s, M30s. And the repair method, so is almost the same as M30s. Also, this input voltage, you need to have a calculation as the M30s. The voltage of chip clock, the voltage need 0.15 volt, and the same, the LDO. The LDO have some difference. Just I have measured. This is the main difference with the before series. The other keep the same. So you know how to repair the M20s and the M30s series. Then you know how to repair the M50 series. The repair is the same. The chip is 68. You need to load this. Now I think the training is completed, and that's all for this information. Thank you who intended this training. Thank you for your time.